Okay, so let's do practice quiz 11, number 1. Before doing that, let me give you a brief lecture. So in the previous lecture, we presented the z-test, which was a method for testing a claim about a population mean, given that the value of the population standard deviation, sigma, is known. So today we present the t-test, which is a method for testing a claim about a population mean when we do not know the value of sigma. So in practice, the t-test is extremely useful since realistically, the population standard deviation is not something we would know. There's 3 different types of t-tests. First one is called a one sample t-test that compares a sample's mean with a known value when the population standard deviation is unknown. 2, we have a paired samples t-test. So that's how you can think of this as measurements of the same group of people are taken before and after some treatment. Okay, and 3, independent samples. That's sample taken from 2 different populations, no before and after measurements. Okay, so some assumptions about the t-test. That the data collected is collected randomly. The data is approximately distributed normally. If n is greater than or equal to 30, then we should be fine there, but the central limit theorem. And here's the R code for running a t-test. So we're not going to be using a z table like we did in last quiz. We'll be doing everything now using R. Okay, so let's go to the question here. So suppose the sample below represents the ages of a random sample of 30 students at AVC. So here's a sample here of our ages. Suppose the mean population of AVC students 5 years ago was 29. Okay, so we need to write the R code that does the following. So A makes a green box plot of the sample values and labels the main title ages. So let's do part A first, and we'll go through each one. Just take it and put it to the bottom here. So I'll start my R code right here. Well, let's paste it here and I'll put the R code below here. So let's take our sample. It's already set up for us, so I can read it. Okay, so go down. Okay, so now let's do the box plot. So box plot, and it's going to be of our sample above, so this guy. So just make sure you spell it exactly right here. And then the main title, we want to equal ages of randomly chosen students at AVC, right here. And the color is green. Color green. So that should do it. Okay, so we're done with A, so we can take that one away now. Now let's do B. So B, so we've done A, let's take that one away. Let's do B next. Copy this, because I erase it here. Bring it to the bottom. R code so I can see it. So B computes the mean standard deviation of sample data. Okay, so to do that, let's put it below here. So to do the, so let's write this, say print, and let's write number in our sample. All in quotations. So get the number in our sample, we are going to write length. And I'll write our sample here, it has to be spelled exactly like this. So capital S. That'll give us the number in our sample. Let's do the mean next. So I'll do mean, so write print mean of our sample. So to get the mean, you just type mean, and then you're going to put our sample guy here. Again, it's spelled exactly the same, exactly as it's spelled up there. Okay, now we'll do our standard deviation next. Okay, so doing that, standard deviation for sample. Then I'm just going to write, for standard deviation, the function R is just SD. Then it will be, again, sample up here. Okay, so we've done the mean standard deviation of our data, so we're done with B here. Take that away now. Let's now go on to part C. So performs a left tail t-test with alpha 0.01 to decide whether a population mean age has changed from 29. Okay, so let's go to our template above up here. Right here, let's take that and make some changes to it. Okay, so put it below here. Okay, so let's make some changes. Actually, let me take the question and put it below the R code here, so I can't see it. So let's take it here. So performs a left tail. It says, so for where it says numeric vector of data values, that's going to be our sample. So again, spelled with a capital S. We've defined it. So that's going to go here. And it says another optional vector. We don't have any other. We're just doing a one sample, so it's not going to be an optional one here. That's going to be gone. Do that. Okay, and the type of test we're doing is as left tail. So we get choices: two-sided, less, greater. Left tail means less. So we're going to choose the last one. You got that? Our mu here is our H0. Our H0 would be that the average age is 29. So it'll be 29 here. And paired, well, it's not. If you go up to the test up here, it's 3 different types. You have one sample, paired samples, and independent samples. We have, what we're doing is one sample. So actually this part down here, the paired stuff, you can actually take away. That's just for the other 2 types. So we can take that away. And variation equal, that's just for the other 2 types also. We can take that away. And our confidence level is 1 minus alpha. Our alpha here is 0.01. So think of it as, so think of the 1 as like $1. And think of this as 1 cent. So it'll be $1. Take away 1 cent, so you have 99 cents left, so it'll be 99, so 0.99, sorry. We'll go here. Because that'd be 1 minus our 0.01. Just can do it in the calculator. So go 1 minus 0.01. It's going to be 0.99. Okay, so that should be C done. Okay, let's go back up here then. Paste our code into R and run the script. Okay, let's do that now. Let's paste it. Let's go to run our script so we can type in a R command. This. Or just click on the link. Also, that was there. So, logging in. Okay, get rid of this. Paste it. Now let's run it. Okay. Okay, so scrolling down here, we have our output. Let's put that paste that at the bottom of our guy here. And let's put our box plot also. We'll copy that. And paste that also. So you can see, looking at the box plot, the median age looks like it's below 25. So it looks like the mean has changed. Okay, let's take a look up here. There's our output. So you can see number in our sample is 29. Mean of our sample is 24.62. Standard deviation of our sample is 7.447. Okay, so now let's look at the questions now. So we've done D. Paste our protocol, we did that at the bottom. Now let's do F. Looking at the p-value in the R output, decide if there is evidence to suggest that the population mean age has changed from 29. Write the p-value in your conclusion at the top of your R code. Okay, let's take that. Oh, it's a button right there. So let's go down and find our p-value. So go down to our R code here. You should see a p-value right here. So let's take that. Put it at the top. Right here. Okay. Right then, right below here, looking at our output, we have p-value equal to this. So let's write our conclusion then below here. So our conclusion then, put that right here. So now our alpha is 0.01 because that was given in the question at the beginning, and our p-value is less than that because it's 0.001. So now alpha 0.01 and our p-value is less than this. Implies that the evidence suggests that the population mean age is lower than 29. Okay, so we're done with this question. I guess we can take away then the F directions up here. Alright, so we're done.